Hi, in this video I'm going to go through electronic displays, from Nixie tubes to LCDs to OLEDs. Meta. The cathode ray tube consists of an electron gun that forms images by firing electrons through a vacuum tube onto a phosphor-coated screen. The electrons cause the phosphor to glow. The more electrons, the brighter the glow. They were the most popular display technology used in television sets and monitors for over half a century and actually led to the discovery of electrons. An electron gun contains a cathode, which is a negatively charged electrode. The cathode is heated to emit electrons, which are drawn away by a positively charged anode. These electrons are focused into a beam using a focusing coil and directed onto the screen using magnetic deflection. In the case of a vector screen, the beam is moved to draw shapes. In the case of a raster screen, like a TV, it scans from top to bottom continuously to form an image. A color CRT adds two more electron guns, and the phosphor coat now is treated with phosphorus that will glow either red, green, or blue. A mask with tiny holes in it uses the fact that the three guns are coming from slightly different angles to ensure that the electron gun intended for the red phosphor only hits the red, the gun for the green only hits the green, and the gun for the blue only hits the blue. By varying the intensity of these three colours, the screen tricks the eye into thinking it sees all of the other colours. One of the coolest looking display devices is the Nixie tube. A Nixie tube is an electronic device used for displaying numbers or other information. The glass tube contains a wire mesh anode and multiple cathodes shaped like numbers or other symbols. Applying power to one cathode will make it glow orange. The tube is filled with a gas at low pressure, usually mostly neon. It is a cold cathode ray tube, rarely exceeding 40 degrees Celsius, and a variant of the neon lamp. Because the numbers and other characters are arranged one behind the other, each character appears at a different depth, giving Nixie-based displays a distinct appearance. Split flap displays were once commonly used in consumer digital clocks, known as flip clocks. A split flap display is a digital electromechanical display device that presents changeable alphanumeric text. Each character position or graphic position has a collection of flaps on which the character or graphics have been printed. These flaps are precisely rotated to show the desired character. These displays were often found in railway stations and airports where they serve as informational display systems, typically showing departure or arrival information. They sound wonderful. Let's enjoy this one together. Flip disk displays are an electromechanical dot matrix display used for large outdoor signs, normally those that will be exposed to direct sunlight. The flip disk display consists of a grid of small metal discs that are black on one side and a bright colour on the other. Along with the split flap display, flip discs have an addictive look and sound which harkens back half a century but still feels like modern technology. They use a magnetic coil to actuate each pixel, which means you only need electricity when changing the pixel, and that each pixel makes a satisfyingly unobtrusive click when flipped. Electromagnetic segment displays work in a similar way, but instead of dots, they have 7 segments to represent numbers. Now here's a weird one, a stroboscopic display. Using this 1960s Russian calculator, it consists of a spinning cylinder that has transparent numbers on it. To display a numeral, the calculator briefly flashes a light behind the required number when it spins into place. Binder view was not a particularly successful display type. They consist of 6 solenoids attached to rods at the rear of the device. A lamp shines through a lens onto the back of the plate assembly. Each plate is a perforated grid designed to represent a graphic, or they could add a colour. When the solenoids activate, the selected plates tilt, interfering with a stationary grid. This causes the light to be blocked in some regions only, letting through the light through to represent a symbol. A plasma display panel is a type of flat panel display that uses small cells containing plasma that respond to electric fields. Plasma televisions were the first large flat panel displays released. They have benefits over LCD screens, including better contrast with deeper blacks, better colour, very little lag, and wider viewing angles. Until about 2007, plasma displays were commonly used in large televisions. By 2013, they'd lost nearly all of their market share due to competition from low-cost LCDs and more expensive but technically superior OLED displays. Manufacturing of plasma displays ended in 2016 as they were obsolete, having been superseded in all aspects by OLED displays. A vacuum fluorescent display is a display device once commonly used on consumer electronic equipment such as video cassette recorders, car radios and microwave ovens. If you have ever seen a display with this blue-green colour, you are most likely looking at a VFD. A VFD operates under the principle of cathode luminescence, roughly similar to a cathode ray tube, but operating at a much lower voltage. Each tube in a VFD has a phosphor-coated carbon anode that is bombarded by electrons emitted from a cathode filament. In fact, each tube in a VFD is a triode vacuum tube because it contains a mesh-controlled grid. Unlike liquid crystal displays, a VFD emits a bright light with high contrast and can support display elements of a variety of colours. Besides brightness, VFDs have the advantage of being rugged, inexpensive, and easily configured to display a wide variety of customised messages. And unlike LCDs, VFDs are not limited by the response time of rearranging liquid crystals. They are also able to function normally in cold, even sub-zero temperatures, making them ideal for outdoor devices in cold climates. Light-emitting diodes were invented in 1962 and were primarily red in colour for the first decade. The first practical LED display was introduced in 1968. They provided a means of small indicator lights and segmented displays for numbers, replacing Nixie tubes. LEDs are the tiny coloured indicator lights you see on electronic instrument panels. They're much smaller and more energy efficient and more reliable than old-style incandescent lamps. It's only with the development of bright and efficient blue and green LEDs in the late 80s that the possibilities opened up for big LED displays. The entire idea of what could be done with LEDs was given a shake-up by the screen design of U2's Pop Mart tour of 1997. With long viewing distances, LEDs could be used to achieve very large images, especially if viewed at night. Egg crate displays use incandescent light bulbs. They were used for scoreboards and the like. A liquid crystal display is a flat panel display that uses the light modulating properties of liquid crystals combined with polarizers. Liquid crystals do not emit light directly, instead using a backlight or reflected light to produce images in color or monochrome. LCDs are available as a dot matrix to display arbitrary images, like in an LCD monitor or TV, or fixed images which can be displayed or hidden, like the 7-segment displays of a calculator or the images in a Game & Watch. LCDs can either be positive, where the LCD creates a dark image, or negative, where the screen is dark and the LCD creates a light image, depending on the polarizer arrangement. So how does an LCD work? An LCD panel has two polarizing films. A polarizer filters light and only lets light through that has a particular orientation. The light hitting the LCD panel is filtered by the first polarizer, so now only light of a particular orientation is getting through. The light then hits the liquid crystals. In their off state, they form a twisting pattern which changes the orientation of the light by 90 degrees. The light then passes on to the second polarizer, which is orientated 90 degrees from the first. Because the light has been rotated, it is now the same orientation as this filter, it passes through and you see nothing. When power is applied to the liquid crystals, they turn to their on state. In this state, they do not rotate the light, so it passes through the liquid crystals with the same orientation it got from the first polarizer. In this case, the second polarizer blocks the light, causing the dark reflected image, or it blocks the backlight. Color LCD screens add color filters to create the red, green, and blue pixels you need. The LCD lets the light through or blocks it to create the images that you see. Electronic paper, also sometimes referred to as electronic ink, are display devices that mimic the appearance of ordinary ink on paper. Although they have only fairly recently come into common use, the first electronic paper dates back to 1970. Unlike conventional flat panel displays that emit light, an electronic paper display reflects ambient light like paper. This may make them a more comfortable read and provide wider viewing angles than most light-emitting displays. Different companies have developed different electronic paper and ink. While the technologies used by each company provide many of the same features, each has its own distinct technological advantages. All electronic paper technologies face the following general challenges: a method for encapsulation, an ink or active material to fill the encapsulation, electronics to activate the ink. Generally, the ink holds a charge, and by exposing the inks to positive and negative plates, the ink will move to the opposite charge. The method of how the inks are encapsulated and then applied to the substrate is what distinguishes one company from another. These processes are complicated and carefully guarded industry secrets. Nevertheless, making electronic paper is less complex and costly than LCDs. Organic light-emitting diode displays contain an emissive electroluminescent layer, which is a film of organic compound that emits light in response to an electrical current. This organic layer is situated between two electrodes. OLEDs are constructed in a similar way to LCDs, but because they produce light through emission, they do not need a backlight. This means they have better contrast and deeper blacks than LCD screens. Also, because they do not rely on liquid crystals reconfiguring themselves, their response times are much faster, meaning the pixels can change much faster. And with that, you are all caught up on the different types of electronic displays. Thank you very much for listening.